Good morning and welcome back from a long weekend. Today we are going to be discussing infinite limits at infinity. So it's infinity all over the place. Alright, so first off, let's talk about what, again, limits at infinity are like. So we're going to find all limits that approach infinity, and we're going to look talking about one-sided limits. So first, I see that over here on the left there is an arrow pointing up. That would be going towards infinity, rising up. So what I would say for that one is that the limit as x approaches, well, that looks like that asymptote's over there at -2, and it's approaching it from the left, all right, of this function is equal to positive infinity. It's shooting off into space. All right, the next place where it's shooting off into space be right here. Same location, x approaching -2, but this time you're approaching from the right of whatever this function is, and we're also getting a positive infinity. But the next place, down here, we've got an arrow that's pointing in the down direction forever. So that would be the limit of this f of x function as x approaches, that'd be a +2, and approaching it from the left is equal to negative infinity because it's pointing down. And then the last point would be here, the limit of this f of x function, this time as x approaches 2 from the right, would be equal to positive infinity. Now one of those has a two-sided limit, and this one over here. All right, because the limits are equal, you can see the limit as x approaches -2 is equal from the left and the right, and then we could actually still say that the limit as x approaches -2 equals infinity. We could drop the from the left and from the right part, since they're both equal. Whereas the other one, they are not equal, so we cannot do that. One's going up, one's going down, so we can't kind of clump them together into one limit. All right, so that's the first little piece, just kind of a reminder of how the limits work and what it means to have a limit at infinity. All right, so here's our steps for today. We're going to break each term into what's called expanded form, and I'll show you how to do that with this example down here below. All right, so what expanded form means is that we are going to rewrite this problem as a group of multiply problems. The whole number 4 times 3 x's. That's what x to the third means. Expanded form means writing it without any exponents, writing it the longest possible way. All right, then we're going to replace those variables with either infinity or negative infinity, depending on what we see right here. This one says, as we approach positive infinity. So what does that mean? Well, that means that this is going to be a very large positive number. This is going to be a very large positive number, and this is going to be a very large positive number, all times this positive number. So we're not so worried about what number we get. We're worried more about the plus and minus sign, because it's going to be infinity. Is it a positive infinity or a negative infinity? So since they're all 4 positive signs, this would be a positive infinity. That's my limit. All right, that means in this graph, there'd be an arrow pointing up to the far right. So no matter what the graph looks like, out here at the far end, you're going to have an arrow headed in the up direction. Not the down direction, in the up direction. It's called end behavior. It's not about what happens in the middle of the graph. It's about what happens at the far ends, out towards infinity and negative infinity. Let's try another one. Very similar, but again, different answer. All right, so let's first off expand that top part out. That's going to end up being 4 times x times x times x. Essentially the same as the last problem. Except what we are changing is what we're approaching. We're approaching negative infinity. All right, so if I'm approaching negative infinity, well, this 4 is going to still be positive 4. But this x is going to be a negative large number. This x is going to be a negative large number, and this x is going to be a negative large number. So you can see when we multiply 4 times 3 infinitely large numbers, we're going to get an infinity. Is it negative infinity or positive infinity? Where in this one, because there are 3 negatives, an odd number of negatives, then that means the answer is negative. If we were to count an even number of negatives, then our answer would be positive. Right? So the work is not crazy hard again. It's more, again, just about learning new concepts and getting used to these limit symbols. We're going to see these all throughout the year. All right. Have a great day and enjoy your day. Good luck.